All right, we're good to go. All right, so digestive system, then let us get started. And in a nutshell, and this would not be news to us, the digestive system breaks down food so nutrients are absorbed by the body. Okay, so that's its primary function, is to provide nutrients so that, of course, things like cellular respiration can take place, because we know without cellular respiration, we do not live, right? So your first question, there are three functions of the digestive system, and here they are. So the first function is obviously to ingest the food and break it down to smaller pieces. And then the next function is to absorb the nutrients. And then the final function is to eliminate what cannot be digested. So yes, we do eat a bunch of stuff that we can't actually even digest, right? So we will eat, and it's, you know, we call it roughage, right? So we eat fruits and vegetables, but we actually do not even have the enzymes to break down plant cell walls like cows do, or rabbits or other herbivores. We don't have the same enzymes. So we eat stuff that we actually can't even digest, right? So it has to be passed through. We eat that stuff because, you know, even though the skin of the apple may not be digestible, but there are other things in the apple, like the sugars, that we definitely can use, okay? And we call this roughage, and roughage also helps for the undigested material to move along and be expelled, okay? So there are three items. Now, you probably know some of this here, right? So what is this dark red structure up here? And let me ask Elijah, what do we call this dark red structure here? Do you know that already? Do you happen to know?
I can't see
Oh,
the screen.
am I not sharing?
I don't I can't see anything. Yeah, now you're sharing.
Oh, thank you. That works better. Okay, so do you see this structure here?
Yeah.
Do you know what that is?
Yeah.
What is that?
The liver.
Correct, right? This is the liver. And notice that there's got this line that goes down through it. Actually, the liver has three lobes. And when you do the rat dissection and you take out the liver, you will kind of spread it out a little bit and you'll be able to see those three lobes, right? And the good thing about the liver is that if you lose a piece, I don't know, through some kind of injury, you get stabbed or whatever, or if it becomes diseased, good thing about the liver is it can regenerate itself. How cool is that? So that's the liver. And then does anybody happen to know, see this little kind of pink bag that's peeking out from behind the liver? Does anyone happen to know what that is?
Is that a kidney?
No, good guess. Kidneys are going to be further down here, right? So kidneys are kind of like, you know, if you reach around to the small of your back and, you know, you put your hand kind of not all the way down, but a little further up, your kidneys are down there, right? This little guy here, that's the gallbladder. And we'll talk about the gallbladder later on. What about this kind of sac-like looking structure here? Anybody know what that is?
The stomach.
That is the stomach. And then we've got kind of like two sets of tubing here. We have this smaller diameter tubing in the middle, and it seems to be surrounded by a larger diameter tubing. What do we call the smaller diameter tubing?
Is that what you call like the small intestine or something?
Yeah, that's the small intestine. And then the one on the outside
Is your larger intestine.
There you go. That's your large intestine, right? So we already know a little bit about the geography of the digestive system. So let's get into the functions. And their digestion occurs in two different ways, mechanical and chemical, right? So mechanical, what do you think would be mechanical? Sounds like machinery involved, right? Mechanical. What would be mechanical digestion, do you think?
Like when you chew?
Exactly, right? Like when you chew. I think that was you, John, but I don't see your face. So when you chew, right? Teeth, right? So teeth is the machinery, not only teeth, but your tongue and also muscle tissue that actually turns the food around and around, making it break up into smaller pieces, right? So that's mechanical. And then chemical digestion, this would be where, you know, a molecule is actually changed into a different molecule chemically by enzymes in your body. This is what we're going to find out about today. So mechanical digestion, this is chewing up the food into smaller pieces and churning the food with smooth muscles in the stomach to break it up into smaller pieces, right? So in your notes, we've already completed number 1, and number 2, explain mechanical digestion. Here you would say breaking up food into smaller pieces by chewing or churning using action of smooth muscles. That's mechanical digestion. The name of the game here is to make the pieces smaller so you increase the surface area. That's what's happening. So you take that hamburger and you know that you got to get those nutrients into a cell, which is microscopic. So you've somehow got to get this hamburger broken down into microscopic pieces. That's going to take some work. Okay. So your chemical digestion then will take those microscopic pieces and break them up even smaller using enzymes. Okay, so the chemical breakdown, and that's your 3, is to break down the molecules into smaller molecules using enzymes. Right, so enzymes, these are proteins that are catalysts. They speed things up. Life depends on enzymes. If your enzymes aren't working, then we're not sitting here, right? You cannot live without enzymes to speed up processes in your body. We're busy people, so we need to supply our cells with nutrients all the time, and we need to do it relatively quickly. So here's an example of chemical digestion. So when you chew bites of pizza, an enzyme in the saliva, which is called amylase, begins the process of chemical digestion by breaking down starch into sugar. So the crust of the pizza is carbohydrate, right? It's kind of like a bread, and bread is carbohydrate. Starch, excuse me, it's starch. So potatoes are starch, rice is starch, pasta is starch, bread is starch, you know, muffins is starch. And so when you put that into your mouth, chemical digestion starts right away with amylase that's in your saliva. Have you ever kind of looked in a mirror and lifted up your tongue and looked right at the base of your tongue, like behind your teeth? You will see 2 little holes in your tongue. I could ask you to do it right now, but we would all look pretty funny, kind of leaning in and looking at our tongues. But if you look closely, next time you're in front of the mirror, brushing your teeth, whatever, lift up your tongue, look at the base of your tongue, and you'll see 2 little holes there. That is where the saliva comes shooting out of those holes, right? And saliva, and also other ions like carbonate ions to make your saliva more alkaline. And because it's right behind it's at the base of your tongue, right behind your lower teeth, this is why you often will get a buildup. The dentist will tell you, oh, you've got buildup on your lower teeth. You get a buildup of kind of like it's a substrate, but it's because the saliva is ejected right there behind your lower teeth, okay? And it's basic because you have bacteria in your mouth breaking down food that's left between your teeth, and the bacteria will excrete a waste, which is acidic. And that acidic waste will make holes in your teeth. We call those cavities. This is why saliva is alkaline, to neutralize the acidity of the bacteria. Okay, so you guys have answered question 4. So the tongue forms a bolus that travels down the esophagus. And we talked about the esophagus when we talked about the respiratory system, to say that the esophagus is another tube that runs behind your trachea. Okay, so this is just a quick video to show you, right? This is a bolus. A bolus is just a big lump of food. See, the epiglottis reaches out and guides that bolus down the right tube, which is into your stomach, and not the wrong tube, which would be into your into your trachea and your lungs, and you would choke, right? So we got to get it going down the right tube, and the epiglottis guides it that way. Okay, so that little flap of cartilage is extremely important. Okay, so question 5, let me ask, Lea-Carol, how did you answer question 5?
I said the epiglottis.
Right, the epiglottis, right? So the epiglottis. So here's the alimentary canal, right? So it starts in the mouth, esophagus, into the stomach, small intestine, large intestine. It's just like a canal. It's all been wrapped up. But you have these accessory organs. So you have the liver, the gallbladder, the pancreas, and the salivary glands. And your next question here is, what is the function of the gallbladder? And I said I would come back to it. So the gallbladder stores bile, right? So your answer there would be the gallbladder stores bile. And the gallbladder is this little structure in green here you see tucked behind the liver. Let me ask you, has anybody been so sick that you throw up like so frequently and so violently that you end up throwing up green stuff? Okay, John has, Dominic has, a bunch of you have. All right, well, sorry to hear that you were sick. Can you just tell me a little bit about that experience? So John, what was that experience like for you? Why were you throwing up so much?
Oh God. So I had the stomach flu, and that was horrible.
Yeah.
So I kept throwing up. And like when you throw up that green stuff, it stinks. And it burns, and it's not fun.
Right, so it stinks, it burns, and it actually has a very particular taste, right? It's quite salty, right? And it has happened to those of us who, and this is because if you get to the point where you are throwing up bile, and it's green. So when you get to the point where you're throwing up green stuff, you're throwing up bile. And that means that you are in fact pretty sick, right? That you have got absolutely nothing left to throw up, and you are now actually throwing up bile. And bile helps to break down fats. And we'll get back to that a little bit later. And salivary glands, of course, salivary glands are here. You've got several of them, some right behind your lower teeth here. And then the others are here, right along your jaw. And they will secrete saliva. The liver secretes the bile, and the gallbladder stores the bile. Okay, so that's how that works. And then
I have a question.
Yes.
If you had to have your gallbladder like removed, what would that mean?
So you would then go on some form of medication to make up for the loss of bile, and you would also have to change your diet. So bile breaks down fats. So folks who actually do end up, they get a lot of gallstones, and then perhaps the doctor says you got to have your gallbladder removed. It happens. But then you would be advised not to have a high fat diet, because now you have just lost the thing that breaks down fats, right? And you would be given some form of a substitute to take the place of bile. But yes, some people have the gallbladder removed because they end up getting these gallstones. Pancreas, this feathery looking structure here, pancreas super important because the pancreas secretes these digestive enzymes. Without the pancreas, you are not be able to break down your food. It is just going to pass through your system. You'll have a horrible case of diarrhea. You will not be able to digest food. People who have cystic fibrosis, not only does the mucus collect in the alveoli of their lungs, but mucus also, you see this duct here, these tubes? Mucus collects in those tubes. And if mucus collects in the tubes, the digestive enzymes are not able to spill into the small intestine. And so they end up being severely malnourished, right? Pancreas, super important guy. And yes, some folks get pancreatic cancer, and that's not a fun one to have, because this secretes the enzymes that allow you to break down your food. A lot of important structures. So question, where is the liver located? And who wants to answer that question? So Zayden, let me ask you, where is the liver located? How would you describe that? Oh, that's right. Zayden, your mic is not working. You're putting it in the chat. Okay, let's see. Where is my chat? Okay. So Zayden, if I could ask you to put that in the chat. So Nalu, maybe I can ask you, where is the liver located? How would you describe that?
Like above the stomach,
Mm-hmm. And to the left or the right?
to the right.
Right, to the right of the stomach. And I put this question here because sometimes, for whatever reason, people think the liver is lower down. It's not, it's all the way up here. So when you have an injury, right, up here, you risk impacting the liver, right? Because it's pretty high up here, right, next to the stomach. So let's just take a look at these. I'll just go down my list here. Let me start at the bottom this time. So Ahi, what would you call number 1 here? What is that pointing to?
That is pointing to your nasal path. Wait, no, that's your mouth.
That's the mouth, right? So this is digestive system, so that'll be the mouth. And then if I could ask Kylie, what is 2 pointing to? The structure that is behind your lower teeth and also here on your jawline. You know what those are?
I don't know.
Salivary glands, right? So the salivary glands are located here. And then number 3, Makamai, this is for you. What is this pointing to, this little structure we just talked about?
I want to say it's the gallbladder. I don't know.
You would be correct.
Okay.
Question mark out of your voice, right? Because you're absolutely right. It's the gallbladder. This is the gallbladder. And so 4, Ryan, is pointing to
The liver.
the liver. And 5, Dara, is pointing to this feathery structure here.
Pancreas?
Correct, the pancreas. And Uakea, 6, is pointing to this skinny tube here.
Small intestine.
Small intestine. And so Jada, 7, is pointing to this tube here.
Esophagus.
The esophagus. And John, 8, is pointing to this structure.
Stomach.
That's the stomach. Journey, number 9, is this one here.
Your large intestine.
Large intestine. Nalu, 10, is pointing to this area here.
I don't know, colon.
The colon is another term for the large intestine. If I go back by 1, this area right here.
Oh, the rectum.
The rectum, right? So that's the rectum. And then finally, number 11, Dominic, is pointing to
Anus.
anus. Okay, so that's the geography. Now, in your guided notes, you have a picture there. So let's go ahead and label that picture. All right, so it's Elijah's turn. Elijah, what is the long tube in your diagram in your notes? What is that? The esophagus. Yes. And Kingston, what is the red structure in your diagram?
Liver.
The liver. And Ikuhai Kalani, what is the green structure?
Gallbladder.
Gallbladder. And Ahi, what is the orange structure?
With the orange structure.
Yeah, the orange structure. How are you labeling that? Ahi. You see the orange structure there in the diagram? Are you with us, Ahi? So the orange structure, maybe we can ask Zion. Is Zion with us? No, Zion's been dropping in and out. So back to you, Kylie. Orange structure
Is the stomach?
is the stomach, correct? Yeah. And Makamai, so what is the light yellow structure?
The small intestine?
Small intestine. And Ryan, the dark yellow structure is?
The large intestine.
Large intestine, okay? All right, so we talked about the epiglottis. We know where the epiglottis is and what its function is, right? So its function is to guide food into the esophagus and away from the trachea. And so the function of the esophagus is then to transport food from the mouth to the stomach, right? So that's the function of the esophagus. And that is question 9. What is the function of your esophagus, right? So the function of your esophagus is to transport food from your mouth to the stomach. And as it does so, of course, the smooth muscle here that contracts and relaxes to move the food towards your stomach. And so for the stomach then, before I do the stomach, question 10, who wants to answer question 10? Uakea, how would you answer question 10? When a person swallows, a small plate of cartilage covers the trachea. What was this piece of tissue called?
Epiglottis.
Yeah, the epiglottis, right? The epiglottis. The epiglottis. All right, so to the stomach then. So we've gone from the mouth, down the esophagus, to the stomach. And the stomach has a couple of sphincters, right? So a sphincter is a place where there is circular muscle that when it contracts will actually close off a tube. So there's a sphincter here at the top of the stomach, and there's also a sphincter here at the lower end of the stomach. And so in the stomach, you have these layers of smooth muscle that churn food around, right? So this is kind of like a washing machine in here, right? So the food comes in and you've got all this juices in here, and the stomach will literally contract and relax like a washing machine, and it's turning and turning and turning all the food around to get it into smaller pieces and make sure it's nicely covered and soaked in the gastric juice, right? So this does a lot of churning around. So why do you think we have a sphincter here? It's kind of like an on-off tap, right? It can close off. Why would we have a sphincter that closes off at the top of the stomach?
So it keeps your stomach juices in.
Yeah.
Out your esophagus again.
Right, exactly right. So it keeps your stomach juices in your stomach, and it doesn't have them splashing up and going back up this pipe. Has anyone ever experienced, sometimes they call it heartburn or acid reflux? Never had that? Never heard of anybody have that? Yeah, some folks have acid reflux, and it feels like this burning sensation right here in their chest. And it's because their sphincter here was kind of leaky. And so some of this gastric juice came back up the pipe, up your sphincter. And this is pretty acidic stuff. And so it feels like it's burning. Sometimes pregnant women will get this because they're pregnant. They got this big bump, right? So they got this big fetus there, and it puts pressure on the stomach and pushes the stomach up to the point where sometimes the gastric juice, even though you have a sphincter, some of the gastric juice will leak through here, and they get this feeling of heartburn. Okay, so the job here is to keep the gastric juice in the stomach and prevent it from going back up the esophagus. And the other sphincter is this one here, the pyloric sphincter. So, excuse me, let me go back here. The pyloric sphincter, again, is like you can squeeze this tube closed. And this allows enough time for all your food to get, moved around in the stomach and finally, coated fully with gastric juice and broken up. And then when it's been properly processed, only then will it go into your small intestine. You don't want large chunks of hamburger ending up in your small intestine. Okay, so you want this all kind of nicely broken down and mixed up until it kind of has the consistency of tomato soup. And then when it has the consistency of tomato soup, now your pyloric sphincter will relax and allow it to trickle down into your small intestine. And then it will contract again so that not too much goes down into your small intestine at one time. See, Uakea is eating breakfast. So her digestive, see, this mechanical digestion happening right there, Uakea. Saliva is being secreted in your mouth. Amylase is breaking down whatever that was. Cereal? I bet there's a lot of starch is what you're eating. What are you eating, Uakea?
French toast.
Toast. See? Starch. So you have amylase right now breaking down the starch into sugars. Yes, and that's why it tastes sweeter after it's been in your mouth for a little bit of time. Okay, so now we are in the stomach. Okay. Oh, let's back up. Question 11. What is the function of the esophageal sphincter? So let me ask. Journey, what is the function of the esophageal sphincter?
Isn't it like to prevent air from entering in the esophagus?
To prevent air
that's what I
from
thought.
entering the stomach? No, it's not to prevent air from entering the stomach. Dominic, can you help us out? What is the function of the esophageal sphincter?
Prevents the gastric acid in your stomach to go back up the pipe.
Correct. And what do we call the pipe?
The esophagus.
There you go. Right. So function of, this is question 11, function of the esophageal sphincter is to prevent backflow of gastric juice into the esophagus. Okay. And Elijah, can I ask you, what is the pH of gastric juice?
Like 2 oranges, lemons. I'm just kidding.
Okay, it's 2, right? So the pH of gastric juice is 2, like lemon juice, right? And in your stomach here, you have this enzyme called pepsin, and it breaks down proteins, right? So pepsin works in a very acidic environment, and it breaks down proteins. And your stomach is also lined with a bunch of cells that secrete a mucus that actually protects your cells from the pepsin. So you don't digest your own stomach. What a concept, right? So we don't want to be digesting our own stomach. So we have this mucus that is secreted constantly, so pepsin isn't actually making a hole in your stomach, okay? So your juices are very acidic, and this is to protect you from the stuff that you eat. Anytime you put something in your mouth, just as Uakea did, guaranteed you're eating some bugs too, right? Some bacteria. Yeah, it's very hard not to, right? You're putting that stuff in your mouth. So you eat, so here's a story. Who likes mangoes? I love mangoes, right? So I love mangoes. And so I was eating this mango, and this is when I lived in Mozambique. And, I had the whole mango, right? I'm kind of chewing away at it. And then at some point I pulled back, and I noticed that on the pip of the mango, there was kind of like this discoloration. And I was just looking at it when it moved. The discoloration moved, and out of the pip came this beetle. And this beetle was about, it was about the size of the top of my little finger. And this is after I had eaten most of the mango, right? This beetle comes crawling out of the pip. Oh, it was just like, so I was like, okay, I hope I didn't eat a beetle. I mean, I saw one, and then when I looked at the rest of the mango, there were lots of them in there. And then there were little tiny eggs that it had laid in the mango. And I had just eaten this thing, right? So yeah.
You know, I would think that they would be like crunchy or something, or like at least taste off. Like,
Yeah.
John, with all due respect, I cannot handle this today. Okay, I cannot handle that. I
what? But
need
I
you
mean,
to
it's
stop.
it's a mango. Mangoes are soft. Like if you're eating a mango, you would like there would be crunch.
Okay,
And that's not.
this story. I got to tell you this story now. So maybe I've told you this story before. Have I ever told you the story about when I did the lab with the kids and we were growing bacteria? And so we had a bunch of petri dishes with medium in them. Do you know how to, have you ever seen that kind of lab where you know what a petri dish is? Yeah, so petri dish, and you put in agar and it solidifies, and then you can like pop, see how quickly bacteria grow. Okay, so I was doing this lab. This was in Uganda. And so I had all the kids and I said, okay, what we're gonna do, this was after lunch, right? After lunch, wash your hands. So they all washed their hands. What's Ahi doing? Ahi, are you with us? Maybe I should ask Miss Wilson to go down to the Ho'okanaka Center and see what Ahi is doing.
He's right there.
He's right here. Can you tell him to turn around and pay attention? Hi, Ahi.
Turn around and pay attention.
Thank you.
Turn around and pay attention.
So here's what
She said to turn around and pay attention.
We have the petri dishes. They're full of the medium. I had my students wash their hands. This is after lunch. And I said, just with your fingers, just gently touch the top of the medium. Well, you just touch the top of the medium, and we'll put those petri dishes into the incubator and incubate them for 2 days, come back and see what bacteria have grown, right? And I wanted, it was kind of like an exercise, like how well did you wash your hands? And so I come back to my incubator, and before I opened the incubator, I could see, it looked like someone had taken a bag of rice and thrown it at the incubator. There was like this rice all over my incubator, these tiny little pieces of grains like this. And then I looked more closely and they were moving, right? They were maggots. So here were maggots and they were crawling out of my incubator. When I opened the door, here are all these maggots. They looked like little grains of rice and they were all moving and they were white and I noticed they were coming from one petri dish. And of course, the students had put their names on the petri dishes, so we knew exactly whose petri dish it was. So what the student had done is when and it was a boy, when he put his fingers onto the medium, he kind of pressed a little bit too much. And so some of the medium went under his fingernails. And so when he took his hand off, whatever was on his fingernails had actually been caught in the medium. Well, what was under his fingernails were eggs, right? Of flies, of something. And so they had just, been given this medium to grow on and nice and warm. And they hatched into little larvae and went crawling all over my incubator. Anyway, why do I tell this story? Because you eat this stuff. And fortunately, your gastric juice has a pH of 2, and so it will actually kill off most of those nasties that you just ate. All right. All true. Okay, so let's see. Who's going to answer question 13 for me? Kingston, what is the answer to question 13? Where does the digestion of proteins occur? Digestion of proteins. Pepsin digests proteins in the
Stomach.
In the stomach, right? Pepsin digests proteins in the stomach. Oh, question 14. What digests proteins? Ikuhara Kalani.
Pepsin.
Pepsin. Okay. Pepsin. And the pH scale runs from 1 to 14. So what is considered to be neutral, Elijah? Where is Elijah?
I think we should go drinking 14, yeah?
So Elijah,
Or 12, yeah, I know. I should drink 12, yeah.
Elijah, what is neutral? What pH is neutral?
14?
No, 14 is very basic.
Oh, so that one's good for you, yeah?
So if the
I'm
pH
kidding, I'm
scale
kidding.
runs from
Seven,
1
seven.
to 14,
I was just
what
kidding,
would,
it's 7.
what would be in the middle?
7.
7, right? So 7 is in the middle. And so that's your answer to question 15. And what is one substance that normally has a neutral pH? Elijah?
Bleach?
No, a neutral pH.
I'm just kidding. Water.
Water, okay?
Pure water.
So water has a neutral pH, and that's why we drink water. We are watery organisms. So let's see, question 17. Acidic substances have a pH between what and what? So this question is for Jada. Between what and what is acidic?
1 and 2.
1 and?
6.
Right, so 1 and 6 is acidic. You're going to be using the pH scale a lot next year in chemistry. 1 and 6 is acidic, and so therefore what is basic between what and what? So, Wakea, what is considered to be basic? What pH?
Bleach and
Yes, and the number though, what number?
14.
14 through
8.
8, right? So 8 through 14 is basic, right? So you can see some examples here of what is acidic and what is basic. So Dara, can I ask you question 19? Is gastric juice acidic or basic?
Acidic.
It is acidic, okay? All right, so the small intestine. So the small intestine, let me just, question 20, if the esophageal sphincter is faulty and allows leakage of gastric acid into the esophagus, what could happen? And let me ask Makamai, what could happen for question 20?
You would get heartburn?
Yes, you would feel heartburn. Because, why would you feel heartburn?
Because your stomach acid is flowing into your esophagus.
Correct, right? So you would get heartburn because stomach acid is flowing back into your esophagus. That is your answer for 20. And Kylie, I'm going to ask you, what is the function, what is the role, excuse me, of the pyloric sphincter? So Kylie, this is for you, question 21.
Does it how do I say this? Does it like close off the exit until the foods are fully broken down?
In the stomach, correct. So it closes off, prevents food from entering into the small intestine until it has been completely processed in the stomach. Okay, so that's your answer for question 21. All right, so let's move on to then 22. So your small intestine is the longest part of your digestive tract. It's about 7 meters long. Who knows what that is in feet? Because I know most of us use feet. 7 meters in feet would be
21.
about 21 feet, right? So look at the room that you're in. I know some of you are in the Ho'okanaka Center, so you're in a big room. But look at the room that you're in, and how wide do you think your room is? Nalu, how wide is your room?
Like 12 by 8.
Okay, so it's about 8 feet wide. So how many, if you were to take your small intestine and drape it across your room, how many times would it go back and forth?
Like a bunch of times.
Like a bunch. Like, what's a bunch?
I don't know, a little over like 2 times.
Yeah, about 2.5 times, right? So that is kind of gives you an idea of how long your small intestine is, right? And then you look at your itty bitty tiny little bodies there, and now we know why it's all kind of wound around, because you're going to get 21 feet of tubing into this small space, okay? And yes, so mechanical digestion continues here because the food continues to be squeezed to break it down into even smaller pieces.
I have a
So,
question.
yes, question.
So the small intestine, it says that it's 21 feet,
Yes,
but like, wouldn't it be different for everybody?
yes, it is. It is different.
The average?
So yeah, that would be an approximate, right? Correct. It is going to be different for different sizes of people, but approximately. Okay. So question 22, why is a small intestine considered small if it is 7 meters long? And so John, what is the answer to that question?
The diameter is smaller than that of the large intestine.
Correct. Diameter is smaller than that of the large intestine. And Kylie, true or false? Both mechanical and chemical digestion occur in the small intestine.
False.
This is true, right? So mechanical digestion does continue to take place in the small intestine as well as chemical digestion. Okay. So the small intestine, this is where most of the absorption takes place, but we do have these 3 accessory organs, the pancreas, the liver, and the gallbladder, which we've talked about before. So your question 24 there says, digestion occurs in the small intestine due to 3 accessory organs. List both organ and function. So Ahi, what is the first organ that you are going to list?
The first organ that I'm going to list would be my liver.
Would be the liver. And what are you going to put down as the function?
It produces bile, which helps break down fats.
Okay, that's the first one. And then Ikuhakulani, what will be the second organ that you'll list?
The gallbladder.
The gallbladder, okay. And what will you put down as the function of the gallbladder?
To store bile.
Right, stores bile, right? So the gallbladder stores bile, which breaks down fats. And then the third accessory organ, Kingston, will be so we've listed the liver and we've listed the gallbladder. So what is the third accessory organ that you have there?
Pancreas.
The pancreas. And what will you put down as the function of the pancreas?
Produces enzymes.
Right, produces digestive enzymes, right? Produces digestive enzymes. Okay, so now we're in the small intestine. We're going to talk about these guys here called villi or villi. And so they're like these projections, just as cilia are projections from cells in our nose and in our trachea. Villi are also projections from cells. And their function is to increase the surface area for absorption to take place, right? So all of these projections increase surface area. And if you were to flatten them out, so if you were to take your small intestine and iron it out, you would have the surface area approximately of a tennis court. Again, amazing that all of this fits into the size of our bodies, right? So function of these villi is to increase the surface area for digestion to occur, for absorption to occur, put it that way, for absorption to occur. And if you take one villus, this is what it looks like, right? And the blue and the red tubings here, this is your bloodstream, this is a capillary, and you can see that fats and vitamins and glucose and amino acids and water are absorbed into the bloodstream across the cell membranes of the villi here. So where in the body does most absorption of nutrients occur? So let's see, is Zion with us? She drops in and out, no. So let me ask Ryan, where does most absorption occur? Where
I'm not sure.
Ryan.
I'm not sure.
Okay. So a villus, where would I find a villus if I was to go looking for one?
Oh, the small intestine.
The small intestine, right? So most chemical absorption occurs in the small intestine. So what kind of transport does glucose need? So all nutrients except for glucose and amino acids enter through the villus by diffusion. Glucose moves into the capillaries by facilitated diffusion, right? So Dara, how are you going to answer that question? What kind of transport is used to absorb glucose into the bloodstream?
Facilitated diffusion.
Correct, facilitated diffusion. And so if we remember back to diffusion, does facilitated diffusion require energy? Yes or no, John?
No,
No. And why not?
because it's just doing like its natural thing.
Natural thing. So let me give you a clue. So active transport requires energy because you move molecules from a low concentration to a high concentration against the gradient. Why does facilitated diffusion not require energy?
Oh, because it's like rolling a ball down a hill.
Correct. So in other words, the molecules are moving from a,
Higher concentration to a lower concentration.
yes, that is your answer for why or why not. Because molecules are moving from a higher concentration to a lower concentration. So we're just going to take a look at peristalsis. Let's see if I have some audio.
Stomach and move chyme through the small intestine and large intestine. The alimentary canal is a single continuous tube that includes the oral cavity, esophagus, stomach, and intestines. The tissue layers that form the walls of the tube include 2 layers of smooth muscle. The contraction and relaxation of these muscles is called peristalsis. One peristaltic wave can be enough to move a bolus down the esophagus and into the stomach. In the intestines, the waves are smaller and more regular. As one section of the intestine contracts, the section in front relaxes. This occurs in the rhythmic, wave-like patterns that create the peristalsis that propels substances forward.
Okay, so that's peristalsis. So you have a question there that says, describe peristalsis. So go ahead and answer that question. Describe peristalsis. You can see it here as well, right? So it's these wave-like contractions that propel digested material forward. So we have smooth muscle that contracts, propels this bolus forward. The area in front of the where it contracts is relaxed, right, in order to receive that bolus and propels food forward. And peristalsis is controlled by the autonomic nervous system. So that's your answer for 30, autonomic nervous system. And we were introduced to the autonomic nervous system when we looked at respiration. Breathing is controlled by the autonomic nervous system. You don't have to think about breathing, thank goodness. It just happens by itself automatically. Same with digestion. You don't have to force your body to digest. It just does it automatically. So your answer for 30 is autonomic nervous system. Okay. Your large intestine. So your large intestine receives this remaining food, and it's in a semi-liquid form we call chyme, right? So chyme is now the material that you can't digest. Well, very little digestion occurs, I should say. A little bit of digestion occurs in the large intestine, but the stuff in here is called chyme, right? And chyme will then move through the large intestine by the same process of peristalsis. The primary function, however, of the large intestine is to absorb water. So your answer to 33, what is the primary function of the large intestine? That is to absorb water. And I know we still have 30 and 32 to go, but I do want to show you this one last thing before we run out of time. This is a pretty amazing piece of footage that I want to show you.
And with her new teeth, she can take on more solid foods. Digestion starts in the mouth. Teeth grind up the food. Then, special glands under the tongue pump out saliva to help break down and lubricate the food on its 12-hour, 13-foot journey through the gut. It'll pass from the stomach into the coils of the small intestine before finally passing into the large intestine. Waves of contracting muscle keep the food moving, a process called peristalsis. These contractions are so powerful, we can even eat upside down. For the first time, a new camera shows a high-definition view of how food travels through our bodies and into our stomachs. Food enters the stomach through a hole at the top. The stomach is a bag of muscle that churns, squashes, and squeezes food into liquid. At the same time, acids break the food down. The stomach walls protect themselves with a lining of mucus. Without it, the acids could digest parts of the stomach itself, causing stomach ulcers. About an hour later, the stomach squeezes the broken down food out through a tiny hole called the pyloric sphincter. The food enters the small intestine, an 11-foot coil of tube where we absorb most of the nutrients. The interior wall of the small intestine is lined with millions of microscopic projections called villi. These increase the surface area of the gut, making it easier to absorb nutrients. First, the pancreas pumps out a juice that neutralizes stomach acid. Then bile from the liver breaks down the fats into tiny droplets. Smaller droplets are easier for the intestine to absorb. After an hour and a half, the small intestine has absorbed most of the nutrients from the food. It's time for what remains to move on. It enters the large intestine through this, the ileocecal sphincter, a valve that keeps our food from going back where it came from. What's left is a mix of waste food and dead cells from the walls of the gut. The large intestine's main job is to extract water from it. Lots of bacteria live here too, but it isn't because of an infection. We actually need them. They produce enzymes that break down complex carbohydrates in our food, carbohydrates we couldn't otherwise digest. Finally, after about 12 hours, we expel what's left of our first meal.
Okay, and there you have it, right? Digestion in full. Okay, there was one thing here that I wanted to ask you guys is, has anybody here ever had their appendix out? No? Have you ever heard of people having appendicitis? No, really? No one's ever heard of appendicitis?
Like I watched this YouTuber, like he's a doctor and he talks about like all these medical conditions. Like I've heard of it, but like I don't really know what it is.
And that's where you heard about appendicitis. Yeah, I mean it's not completely rare. I mean, I must say that in my career, I mean, I have at least, one or two students who have appendicitis, like, I don't know, every other year or so. It's true. I haven't heard of anyone here at KS having appendicitis. It's not unusual. I mean, it happens, right? You see this little thing on my, this little thing here, the appendix. It's a little kind of tube. I mean, it's part of the large intestine. It's a leftover from our evolutionary past, right? So other mammals have an appendix that serves a function. Ours does not. It's just this little, it's an appendix, right? It's just this little piece attached here to the large intestine. And what can happen is that this, remember, is now undigestible material. And sometimes, because peristalsis maybe isn't working very well, a little piece will slip back into this tube. And notice it's blind ending. It's not going anywhere. So if you have any digested material slip into this little tube here, it's just going to be broken down by bacteria. And the bacteria are going to release their waste product. And it's not going anywhere, and it stays there, and it festers, and it gets worse and worse. And you end up having severe abdominal pain in your lower right-hand side. And if you ever have that, you should actually tell someone right away. And it's pretty severe, right? I mean, it's not just a little ache. It's a pretty sharp pain, and you can feel it if you kind of press in that area. You should go to the hospital right away, because if this thing bursts, and it can burst, right? If the appendix bursts, everything that is in it, which is all that toxic material produced by the bacteria, is now released into this area here, and can be taken up by your bloodstream. Now that's toxic material, and you may end up getting sepsis, which is a kind of blood poisoning. So yes, it can lead to kind of life or death situations if you don't take care of the appendix right away. And so this is why when people do have appendicitis, it's like right away you call the ambulance, you get them to a hospital, you cut them open, and you take it out before it bursts and releases all of that toxic material inside the body. Because then, like I said, then it will be absorbed into the bloodstream and you'll end up with blood poisoning. So that is the appendix right there. So you can see it's in the lower right-hand side. Very distinctive. I have not had appendicitis, but the people I've talked to who have, they say that it's, it's a pretty distinctive, sharp pain right there. All right, so let's just, we're almost out of time, but we can quickly fill this in. So you only have one more question. Let's do number 31. Why is peristalsis important? Jada, why is peristalsis important?
It's important because
Peristalsis.
Question 30? Oh no. What question?
31.
31.
31. Why is
it's important because it moves the food from the esophagus.
Right, it moves it down the alimentary canal, right? So it moves digested food and waste product down the alimentary canal until it is finally expelled. If peristalsis doesn't occur, right, sometimes people get constipated, right? It means that this food, this digested or partially digested material is just sitting there in your gut, right? It's sitting there in your intestine, and it just continues to be broken down by bacteria. And that's also not a good thing, because remember, bacteria give off wastes, right? And so that waste product, you want it to move along, okay? All right, guys, you have what is chyme? That's easy. And then question 34, you have to finish up. So you actually only have 2 more questions to finish up on your guided notes, right? I have a hard copy right here. So you have this last one here. And then you have the discussion piece on digestive ailments, right? That assignment that's on Canvas. All right. Retakes on bell ringers will have to be next Friday because we don't have office hours this Friday, right? So you can do a retake on a bell ringer, but it will be Friday the 20 something, Friday the 29th. Okay. All right, those of you who haven't filled in the crime scene form, fill that in ASAP, and anybody who's thinking of doing the digestion on campus needs to let me know today. All right, can I say a hui ho?